Welcome back. It's 4 p.m. Sun is shining. So let's read a bit more. Reading the Mirage 3. Mirage 3. So it's 4 p.m. Let's read about this electric lightning. I need half a minute to get to my bed.
English Electric Lightning. The English Electric Lightning is a British fighter aircraft that served as an interceptor during the 1960s, the 1970s and into the late 1980s. It is capable of a top speed above Mach 2. The Lightning was designed, developed, and manufactured by English Electric. After he merged with other aircraft manufacturers to form the British Aircraft Corporation, it was marketed as the BAC Lightning. It was operated by the Royal Air Force, RAF, the Kuwait Air Force, KAF, and the Royal Saudi Air Force, ASIF. A unique feature of the Lightning's design is the vertical, staggered configuration of its two Rolls-Royce Avon turbojet engines within the fuselage. The Lightning was designed and developed as an interceptor to defend the airfields of the British V-bomber strategic nuclear force from attack by anticipated future nuclear-armed supersonic Soviet bombers such as what emerged as the Tupolev Tu-22 blinder, but it was subsequently also required to intercept other bomber aircraft such as the Tupolev Tu-16, Badger, and the Tupolev Tu-95, Bear. The Lightning has an exceptional rate of climb, ceiling, and speed. Pilots have described flying it as being saddled to a skyrocket. This performance and the initially limited fuel supply meant that its missions are dictated to a high degree by its limited range. Later developments provided greater range and speed along with aerial reconnaissance and ground attack capability. Overwing fuel tank fittings were installed in the F6 variant and gave an extended range, but limited maximum speed to a reported 1,000 miles per hour, 1,600 kilometers per hour. Following retirement by the RAF on the 30th of April, 1988, many of the remaining aircraft became museum exhibits. Until 2009, 3 Lightnings were kept flying at Thunder City in Cape Town, South Africa. In September 2008, the Institution of Mechanical Engineers conferred on the Lightning its Engineering Heritage Award at a ceremony at BAE Systems, the successor to BAC, Wharton Aerodrome. Development, edit. Origins, edit. The specification for the aircraft followed the cancellation of the Air Ministry's 1942 Specification E.24/43 supersonic research aircraft, which had resulted in the Miles M.52 program. Teddy Petter, formerly chief designer at Westland Aircraft, who had been hired by English Electric in 1944 to head an office to develop aircraft rather than just make other manufacturers' designs, was a keen early proponent of Britain's need to develop a supersonic fighter aircraft. In 1947, Petter approached the Ministry of Supply, MOS, with his proposal, and in response Specification E.103 was issued for a single research aircraft, which was to be capable of flight at Mach 1.5, 1,593 kilometers per hour, 990 miles per hour, and 50,000 feet, 15,000 m. Petter initiated a design proposal with Frederick Page leading the design and Ray Creasy responsible for the aerodynamics. By July 1948 their proposal incorporated the stacked engine configuration and a high-mounted tailplane. Designed for Mach 1.5, the wing leading edge was swept back 40 degrees to keep it clear of the Mach cone. This proposal was submitted in November 1948, and in January 1949 the project was designated 1P by English Electric. On the 29th of March 1949 the MOS granted approval to start a detailed design, develop wind tunnel models and build a full-size mock-up. The design that had developed during 1948 evolved further during 1949 to further improve performance, taking many design cues from the CA-23. To achieve Mach 2 the wing sweep was increased to 60 degrees with the ailerons moved to the wingtips. In late 1949, low-speed wind tunnel tests showed that a vortex was generated by the wing which caused a large downwash on the tailplane. This issue was solved by lowering the tail below the wing. Following the resignation of Petter from English Electric, Page took over as design team leader for the 1P and the running of EE Design Office. In 1949, the Ministry of Supply had issued Specification F23/49, which expanded upon the scope of ER-103 to include fighter-level maneuvering. On the 1st of April 1950, English Electric received a contract for 2 flying airframes, as well as 1 static airframe, designated 1P. The Royal Aircraft Establishment disagreed with Petter's choice of sweep angle, 60 degrees, and tailplane position, low, considering it to be dangerous. To assess the effects of wing sweep and tailplane position on the stability and control of Petter's design, Short Brothers were issued a contract by the Ministry of Supply to produce the Short SB.5 in mid-1950. This was a low-speed research aircraft that could test sweep angles from 50 to 69 degrees and high or low tailplane positions. Testing with the wings and tail set to the 1P configuration started in January 1954 and confirmed this combination as the correct one. Prototypes, edit. From 1953 onward, the first 3 prototype aircraft were hand-built at Samlesbury Aerodrome, where all Lightnings were built. These aircraft were given the aircraft serials WG760, WG763, and WG765, the structural test airframe. The prototypes were powered by UN reheated Armstrong Siddeley Sapphire turbojets, as the selected Rolls-Royce Avon engines had fallen behind schedule due to their own development problems. Since there was no space in the fuselage for fuel, the thin wings were the fuel tanks, and since they also provided space for the stowed main undercarriage, the fuel capacity was relatively small, giving the prototypes an extremely limited endurance, and the narrow tires housed in the thin wings rapidly wore out if there was any crosswind component during takeoff or landing. Outwardly, the prototypes looked very much like the production series, but they were distinguished by the rounded triangular air intake with no center body at the nose, short fin, and lack of operational equipment. On the 9th of June, 1952, it was decided that there would be a second phase of prototypes built to develop the aircraft toward achieving Mach 2.0, 2,450 km per hour, 1,522 miles per hour. These were designated P.1B, while the initial 3 prototypes were retroactively reclassified as P.10. P.1B was a significant improvement on P.10. While it was similar in aerodynamics, structure and control systems, It incorporated extensive alterations to the forward fuselage, reheated Rolls-Royce Avon R24R engines, a conical center body inlet cone, variable nozzle reheat and provision for weapons systems integrated with the ADC and AI.23 radar. 3P.1B prototypes were built, assigned serials XA847, XA853 and XA856. In May 1954, WG760 and its support equipment were moved to IF Boscombe Down for pre-flight ground taxi trials. On the morning of the 4th of August 1954, WG760, piloted by Roland Beaumont, flew for the first time from Boscombe Down. 1 week later, WG760 officially achieved supersonic flight for the first time, having exceeded the speed of sound during its third flight. During its first flight, WG760 had unknowingly exceeded Mach 1, 1,225 km per hour, 761 miles per hour, but due to position error the Mach meter only showed a maximum of Mach 0.95, 1,164 km per hour, 723 miles per hour. The occurrence was noticed during flight data analysis a few days later. While WG760 had proven the 1P design to be viable, it was limited to Mach 1.51, 1,850 km per hour, 1,149 miles per hour, due to directional stability limits. In May 1956, the 1P received the Lightning name, which was said to have been partially selected to reflect the aircraft's supersonic capabilities. OR.155 and Project Selection, edit. In 1955, the Air Ministry learned of the Tupolev Tu-22, expected to enter service in 1962. It could cruise for relatively long periods at Mach 1.2, 1,470 km per hour, 913 miles per hour, and had a dash speed of Mach 1.5. Against a target flying at these speeds, the existing Gloucester Javelin interceptors would be useless. Its primary de Havilland Firestreak armament could only attack from the rear and the Tu-22 would run away from the Javelin in that approach. A faster version, the Thin-Wing Javelin, would offer limited supersonic performance and make it marginally useful against the Tu-22, while a new missile, Red Dean, would allow head-on attacks. This combination would be somewhat useful against the Tu-22, but of marginal use if faster bombers were introduced. In January 1955, the Air Ministry issued Operational Requirement F.155 calling for a faster design to be armed with either an improved Firestreak known as Blue Vesta, or an improved Red Dean known as Red Heb. The Thin-Wing Javelin was cancelled in May 1956. In March 1957, Duncan Sunday's released the 1957 Defense White Paper, which outlined the changing strategic environment due to the introduction of ballistic missiles with nuclear warheads. Although missiles of the era had relatively low accuracy compared to a manned bomber, any loss of effectiveness could be addressed by the ever-increasing yield of the warhead. This suggested that there was no targeting of the UK that could not be carried out by missiles, and Sunday's felt it was unlikely that the Soviets would use bombers as their primary method of attack beyond the mid to late 1960s. This left only a brief period, from 1957 to some time in the 1960s, in which bombers remained a threat. Sunday's felt that the imminent introduction of the Bloodhound Mk2 surface-to-air missile would offer enough protection against bombers. The Air Ministry disagreed. They pointed out that the Tu-22 would enter service before Bloodhound 2, leaving the UK open to sneak attack. Sunday's eventually agreed this was a problem. but pointed out that F.155 would enter service after Bloodhound, as would a further improved SAM, Blue Envoy. F.155 was cancelled on the 29th of March 1957 and Blue Envoy in April. To fill the immediate need for a supersonic interceptor, the Lightning was selected for production. The aircraft was already flying, and the improved P.1B was only weeks away from its first flight. Lightning's mounting fire streak could be operational years before Bloodhound 2, and the aircraft's speed would make it a potent threat against the Tu-22 even in a tail chase. To further improve its capability, in July 1957 the Blue Vesta program was reactivated in a slightly simplified form, allowing head-on attacks against an aircraft whose fuselage was heated through skin friction while flying supersonically. In November 1957, the missile was renamed Red Top. This would allow Lightning to attack even faster bombers through a collision course approach. Thus, what had originally been an aircraft without a mission beyond testing was now selected as the UK's next frontline fighter. Further testing, edit. On the 4th of April, 1957 Beaumont made the first flight of the P.1B XA847, exceeding Mach 1 during this flight. During the early flight trials of the P.1B, speeds in excess of 1,000 miles per hour, 1,600 kilometers per hour, were achieved daily. During this period the Fairey Delta II, FD2, held the world speed record of 1,132 miles per hour, 1,822 kilometers per hour, achieved on the 10th of March 1956 and held till December 1957. While the P.1B was potentially faster than the FD2, it lacked the fuel capacity to provide one run in each direction at maximum speed to claim the record in accordance with international rules. In 1958, two test pilots from the USAF Air Force Flight Test Center, Andy Anderson and Dick Slayton, were given the opportunity to familiarize themselves with the P.1B. Slayton, who was subsequently selected as one of the Mercury astronauts, commented, "The 1P was a terrific plane, with the easy handling of the F-86 and the performance of an F-104. Its only drawback was that it had no range at all. Looking back, however, I'd have to say that the 1P was my favorite all-time plane." In late October 1958, the plane was officially and formally named Lightning. The event was celebrated in traditional style in a hangar at Ray Farnborough, with the prototype XA847 having the name Lightning freshly painted on the nose in front of the IAF roundel, which almost covered it. A bottle of champagne was put beside the nose on a special smashing rig which allowed the bottle to safely be smashed against the side of the aircraft. The honor of smashing the bottle went to the Chief of the Air Staff, Sir Dermot Boyle. On the 25th of November 1958, the P.1B XA847, piloted by Roland Beaumont, reached Mach 2 for the first time in a British aircraft. This made it the second Western European aircraft to reach Mach 2. The first one being the French Dassault Mirage 3 just over a month earlier on the 24th of October 1958. Production, edit. The first operational Lightning, designated Lightning F.1, was designed as an interceptor to defend the V-Force airfields in conjunction with the last-ditch Bristol Bloodhound missiles located either at the bomber airfield, for example at RAF Marham, or at dedicated missile sites near to the airfield, for example at RAF Woodhall Spa near the 3 Squadron Vulcan Station RAF Coningsby. The bomber airfields along with the dispersal airfields would be the highest priority targets in the UK for enemy nuclear weapons. To best perform this intercept mission, emphasis was placed on rate of climb, acceleration, and speed, rather than range. Originally a radius of operation of 150 miles, 240 kilometers, from the V-bomber airfields was specified, and endurance. It was equipped with two 30mm ADEN cannon in front of the cockpit windscreen and an interchangeable fuselage weapons pack containing either an additional two ADEN cannon, 48 2-inch, 51mm, unguided air-to-air rockets, or two de Havilland Firestreak air-to-air missiles. The for anti-AI.23 onboard radar provided missile guidance and ranging, as well as search and track functions. The next two Lightning variants, the Lightning F.1 and F.2, incorporated relatively minor design changes. For the next variant, the Lightning F.3, they were more extensive. The F.3 had higher thrust Rolls-Royce Avon 301R engines, a larger squared-off fin and strengthened inlet cone, allowing a service clearance to Mach 2.0. 2,450 km per hour, 1,522 miles per hour. The F.1, F.1 and F.2 were limited to Mach 1.7, 2,083 km per hour, 1,294 miles per hour. The A.I.23B radar and Red Top missile offered a forward hemisphere attack capability and deletion of the nose cannon. The new engines and fin made the F.3 the highest performance Lightning yet, but with an even higher fuel consumption and resulting shorter range. The next variant, the Lightning F.6, was already in development, but there was a need for an interim solution to partially address the F.3's shortcomings, the interim F.Mk6. Lightning F.3 in flight, 1983. The interim F.Mk6 introduced two improvements, a new, non-jettisonable, 610 imperial gallon, 2800 L, ventral fuel tank, and a new, kinked, conically cambered wing leading edge, incorporating a slightly larger leading edge fuel tank, raising the total usable internal fuel by 716 imperial gallons, 3,260 L. The conically cambered wing improved maneuverability, especially at higher altitudes, and the ventral tank nearly doubled available fuel. The increased fuel was welcome, but the lack of cannon armament was felt to be a deficiency. It was thought that cannon would be useful in a peacetime interception for firing warning shots to encourage an aircraft to change course or to land. The Lightning F.6 was originally nearly identical to the F.3, with the exception that it could carry two 260 imperial gallon, 1,200 L, ferry tanks on pylons over the wings. These tanks were jettisonable in an emergency, and gave the F.6 a substantially improved deployment capability. There remained one glaring shortcoming, the lack of cannon. This was finally rectified in the form of a modified ventral tank with two ADEN cannon mounted in the front. The addition of the cannon and their ammunition decreased the tank's fuel capacity from 610 to 535 imperial gallons, 2,770 to 2,430 L. The Lightning F.2 was an F.2 upgraded with the cambered wing, the squared fin, and the 610 imperial gallons, 2,800 L, ventral tank. The F.2 retained the A.I.23 and Firestreak missile, the nose cannon, and the earlier Avon 211R engines. Although the F.2 lacked the thrust of the later Lightnings, it had the longest tactical range of all Lightning variants, and was used for low-altitude interception over West Germany. Export and further developments, edit. The Lightning F.53, otherwise known as the Export Lightning, was developed as a private venture by BAC. While the Lightning had originated as an interception aircraft, this version was to have a multi-role capability for quickly interchanging between interception, reconnaissance, and ground attack duties. The F.53 was based on the F.6 airframe and avionics, including the large ventral fuel tank, cambered wing and over-wing pylons for drop tanks of the F.6, but incorporated an additional pair of hardpoints under the outer wing. These hardpoints could be fitted with pylons for air-to-ground weaponry, including two 1,000-pound, 450 kilograms, bombs or 4 SNEB rocket pods each carrying 18 68mm rockets. A gun pack carrying 2 Aden cannons and 120 rounds each could replace the forward part of the ventral fuel tank. Alternative, interchangeable packs in the forward fuselage carried 2 Firestreak missiles, 2 Red Top missiles, twin retractable launchers for 44 2-inch, 50mm, rockets, or a reconnaissance pod fitted with 5 70mm Type 360 Vinton cameras. BAC also proposed clearing the over-wing hardpoints for carriage of weapons as well as drop tanks, with additional Matra JL-100 combined rocket and fuel pods, each containing 18 SNEB 68mm, 2.7 in, rockets and 50 imperial gallons, 227 L, of fuel, or 1,000 pounds, 450 kilograms, bombs being possible options. This could give a maximum ground attack weapons load for a developed export Lightning of 6 1,000 pounds, 450 kilograms, bombs or 44 2-in, 51mm, rockets and 144 68mm rockets. The Lightning T.55 was the export 2-seat variant. Unlike the IAF 2-seaters, the T.55 was equipped for combat duties. The T.55 had a very similar fuselage to the T.5, while also using the wing and large ventral tank of the F.6. The export Lightning had all of the capability of the IAF's own Lightnings, such as exceptional climb rate and agile maneuvering. The export Lightning also retained the difficulty of maintenance, and serviceability rates suffered. The F.53 was generally well regarded by its pilots, and its adaptation to multiple roles showed the skill of its designers. In 1963, BAC Wharton was working on the preliminary design of a 2-seat Lightning development with a variable geometry wing, based on the Lightning T.5. In addition to the variable sweep wing, which was to sweep back between 25 degrees and 60 degrees, the proposed design featured an extended ventral pack for greater fuel capacity, an enlarged dorsal fin fairing, an arrestor hook, and a revised inward retracting undercarriage. The aircraft was designed to be compatible with the Royal Navy's existing aircraft carriers' carrier-based aircraft. The VG Lightning concept was revised into a land-based interceptor intended for the IAF the following year. Various alternative engines to the Avon were suggested, such as the newer Rolls-Royce SPI engine. It is likely that the VG Lightning would have adopted a solid nose, by moving the air inlet to the sides or to upper fuselage, to install a larger, more capable radar. Design, edit. Overview, edit. The Lightning had several distinctive design features, the primary being the twin-engine arrangement, notched delta wing, and low-mounted tailplane. The vertically stacked and longitudinally staggered engines were the solution devised by Petter to meet the conflicting requirements of minimizing frontal area, providing undisturbed engine airflow across a wide speed range, and packaging 2 engines to provide sufficient thrust to meet performance goals. The unusual over-forward/under configuration allowed for the thrust of 2 engines, with the drag equivalent to only 1.5 engines mounted side by side, a reduction in drag of 25% over more conventional twin-engine installations. The engines were fed by a single nose inlet, with inlet cone, with the flow split vertically aft of the cockpit, and the nozzles tightly stacked, effectively tucking one engine behind the cockpit. The result was a low frontal area, an efficient inlet, and excellent single-engine handling with no problems of asymmetrical thrust. Because the engines were close together, an uncontained failure of one engine was likely to damage the other. If desired, an engine could be shut down in flight and the remaining engine run at a more efficient power setting which increased range or endurance, although this was rarely done operationally because there would be no hydraulic power if the remaining engine failed. Lightning F.6 XS 904